All right. Thank you for joining us today. I'm John Westcoat, and I run the business development group at TVU. And I am joined by our VP of strategy, Mike Cronk, and from EVS, Dieter Backx, VP of control and orchestration. Today, we're going to get an introduction from Mike to TVU Media Mesh, which was announced for the first time at IBC earlier this month. Media Mesh is a cloud-first modular infrastructure for live media that couples asynchronous microservices with a remote shared memory fabric, providing the flexibility and performance needed to easily build end-to-end live video workflows at any scale within one seamless global platform. And then we're going to get an overview of EVS Cerebrum, what we hope is going to be the first of several collaborations between TVU and EVS, what Cerebrum is, and how Media Mesh has been integrated with some use cases. We will take questions at the end, so please put them into the Q&A tab at the bottom, and then we will answer as many as we can. If we can't get to your question, we will have your email address associated with the question, and the appropriate person from EVS or TVU will follow up after the webinar. So moving on, of a quick introduction for those new to TVU, a flash introduction. We're celebrating our 20th anniversary this year of building a wide range of Emmy Award-winning tools that allow for the quick development and deployment of live video broadcasting, streaming, production, and media workflows that account for over 10 million hours of transmission a year, with 4,000 customers in hundreds of countries around the world. And we're going to hear a little bit more about those from Mike as he introduces Media Mesh and some use cases. Mike, over to you.
Thank you, John. I'm very excited to be here. I'm excited about what TVU is doing. I joined about a year ago, but for the last 10 years, TVU has building a cloud-first microservices-based system, SaaS products. And what Media Mesh really is the opening up of that via API to the industry. And so let me start with explaining the problem that we're solving. So I think everybody recognizes there's a number of potential benefits of doing elastic live media production, the ones that I'm showing here. And there's a lot of press about different installations that have happened, and so quite a bit of buzz. But I've spent a number of years going and talking to media companies about how much of your PCR-based, your production control room-based workflows do you run in the cloud? And on average, that number is 1% or less. And so that really begs the question, why? And there's a number of reasons we'll go through, but the kind of main reason is summarized in this quote, is that in the cloud, I can use infrastructure as code. So things like Terraform and AWS CloudFormation, and you can spin up your compute, your EC2s in AWS, for example, in about 2 minutes, which is fantastic, right? If you think about how long it takes to install an SDI router facility, it's minutes versus months. The problem is that in every production, it takes about 48 hours to get everything connected, configured. And when you compare that to an SDI plant, I go into the room, I fire a salvo, and all my cameras are there. So that's hours versus seconds. So it's a disadvantage for cloud media production. And so let's look a little bit about why that is. First of all, just the economic comparison of that. Took 5 EC2s with 180 total vCPUs, can run about a 20 camera show on that. And let's say we're doing a soccer match for 90 minutes. The cost of that AWS resource is less than $15, so amazingly inexpensive, I think. But if I have to pay somebody in New York or LA to configure that for 8 hours, now I spent $800. And so this is why people say, Mike, it can't scale the way it is now. Uh, and so why is that? Go to the next slide, please. There's actually a couple other reasons I wanted to get into. One is that there still are latency challenges. When I have to have a return that goes back to the field, and if there's SRT delays in the path and processing, and that's 3 seconds late, that makes it very hard for the talent to say goal and then only see it in their monitor 3 seconds later. Or if I'm a director across an ocean directing cameras and I say pan to the right, it may be too late. So one other challenge, though, is something embodied in a study that the CBC did, which is that they surveyed a whole bunch of vendors, and basically people are concerned of vendor lock-in. Why is that? Well, there's a lot of cloud systems up there like run it everything on our platform, but if you do that, how much choice do you have? What happens if that vendor goes belly up? All those concerns are key. And so for these reasons, we're at this kind of 1% number. There are, however, some promising developments, and one of those that we're particularly excited in is MXL. So you may have heard about it at IBC, but this is shared memory so that different applications can share content without having to do an encode decode. It's very light on CPU, and it's also uncompressed, and it's low latency. So very bullish on that. Right now, MXL is at about a version 0.6. So the 1.0, when it's finally released, will have another feature, which is sharing between machines. And that will happen as long as you're in a LAN. And so in AWS, that you need to be in the same VPC, the same account, and that will allow sharing. And that really is the embodiment of what MXL is. It's part of an overall project called the Dynamic Media Facility that the EBU is running. And the keyword there is facility. If you're in a LAN, that's going to work great. But what if I have content that isn't on the same LAN? And how do I share between vendors? And so, the key question is what we show on the next slide, which is how can I use the vendors I want, where I want on a global scale beyond those single LAN boundaries. And we believe a key step in the right direction and answer to that is Media Mesh. One of the key features of Media Mesh is global shared memory, meaning I have a global pointer to a unique identifier, and I can say, give me that media make a shared memory connection to any machine anywhere in the world, and it just happens. And so Media Mesh does that with a global network of compute on multiple clouds and can work on premise. We orchestrate the connectivity between vendors and can drop anything in at MXL at any place in the world. So it's simple live media connectivity, as easy as opening a shared file. And when you think about it, back in the 90s, you'd go in the hotel, try and connect to the internet. You had to do your DHCP. Do I need that or not? Subnet mask, all that was hard. Now you walk into a store and there's Wi-Fi and you just press and it's there. And so that level of simplicity is, we believe, what the industry needs. You can access Media Mesh in 3 different ways. We have an application built on top of Media Mesh. So Media Mesh is the platform, if you will. Media Hub is an application that routes anything in to anything out with a GUI. And so that's one way that you can access it today. Another way is via API to the Media Hub functions that are available. And you'll hear more about that from Dieter at EVS. And we're very, very honored to have EVS with us here today. And a third way that we introduced at IBC is something called the Remote Connection Service. And so whereas Media Hub and its API enable anything in, anything out, frame rate conversion, all those types of things you can do in it, Remote Connection Service is a simple, here's my pointer to the media, make a shared memory connection. So tuned for partners that want just to take advantage of the global shared memory aspect of Media Mesh. And so just to give you a little bit of background on how Media Mesh is built, foundational to it is global shared memory. And then one way to connect is via a connector like MXL, and that's what we're working on with Grass Valley. There's also everything is Docker containerized, and so we're able to take in third-party containers and make them part of the system, which is something that we've done as an example with InSync technologies, which does 50 to 60 hertz motion compensated frame rate conversion. So if you want a really good frame rate conversion, you can use InSync. And representative of working through the platform API is EVS, and you'll hear more about that very soon. And so if kind of summarize Media Mesh, what is it? It's TVU's platform we've been building over the last 10 years. We're opening up at an API level and making global shared memory available so that it can extend what MXL does in a facility or a LAN so that every feed to everyone can be connected.
Right. Thank you, Mike. I think we're going to transition to Dieter here, but I'd like to remind everybody that when Dieter is done, we're going to take questions. So please put them into the Q&A tab at the bottom so that we can answer any questions you have about TVU Media Mesh, Cerebrum, or the combination of both at the end. So Dieter, thank you for joining us today.
Yeah, thank you, John. Great for being here, and it was a great journey to start the first integrations together already a little bit before IBC. So my name is Dieter Backx. I'm based out of Belgium, and I'm the VP for Control and Orchestration. In my portfolio, basically, I have two parts, which is one is the Cerebrum part that I will talk about, which is our control and orchestration system. And then we also have another solution that we announced at IBC, which was our flexible control room part. And also all of that is aligned with the dynamic media facility concepts that also Mike was referring to in the MXL context. So with all of this, Cerebrum is really a broadcast control system that's been there since the long days of SDI. But over the years, of course, what we have invested more and more in is everything that's IP management, but also trying to really give one pane of glass when you're operating. People don't like to go into different applications. It's cumbersome, or you have to give the whole application and user rights are limited. So we give control, configuration, orchestration, and even some level of monitoring to one centralized interface, which can be software-based interface, as you can see on a PC or on a web page, but it can also be on physical buttons. People still in some positions need those, and we really are that abstraction layer. When we look at the next slide, you will actually see that we are integrating with lots of different vendors. We didn't put, of course, all brands in here where we communicate with, but it's all through native APIs, and that's been already there for many, many years, actually plus 20 years. Here we can use the application in different environments, and we can talk to IP fabric, we can still talk to legacy equipment or cameras. And now, of course, with the addition of TVU, we also allow for cloud routing. That is really a big step for us to help in all of the transitions. But again, with the mentality of no vendor lock-in, being open, you build basically your workflows based on potentially even existing equipment that you have, or additions that you would like to do over the next year. So we really are there to help you transition, maybe even from SDI to IP. So what is the integration all about? So Mike spoke about Media Mesh, and the first integration, and as you mentioned, Mike, hopefully many more to come, is the integration of Media Hub. Media Hub is basically a part of Media Mesh that allows routing between different locations, and we'll go into some of the use cases just after this one. But from a Cerebrum perspective, of the screenshots basically that you see here is really the engineering backend. So that's basically where we connect to TVU Media Hub through API calls. And what we actually get back is the sources and destinations, as we would call them, or how you would compare them in a traditional router. But they're called projects within Media Hub. And basically, I can route, for example, from my broadcast facility to a remote location, a remote commentator position, or from that remote commentator position, I can route back into my production galleries that are maybe on-prem. It actually doesn't really matter what it is. Media Hub as such will facilitate that, and Media Mesh, of course, helps to make that connectivity. We also don't have to care too much about the routing capabilities, although we can. It is important that it's actually agnostic to the end user. That's another value that the Media Hub brings. For us, adding a device is quite easy. So we have more than 350 different API integrations built over the last decades. And so here again, we're adding in the next release also the TVU Media Hub connector into it. And that will actually be quite easy to be added as any other device that we have. As always, it's user specific. So it means that from a user perspective, depending on the rights that you have, you might not see all sources and destinations. So again, if you're in your broadcast facility, we can restrict what is visible to some of them and what they can access or basically control, because that's also a difference that you can make. Some might be able to control and others are not. So this is fairly engineering driven. And what you basically see here is more the familiar user interfaces that all of the production staff or sometimes engineers would use on a daily basis. So we'll go to the use cases in just a second, but on the top left, you basically, if you go one slide back, sorry. So if you basically have the top left, you see, for example, when feeds would come into your broadcast facility, they could already be converted by Media Mesh, but there might still be a normalization within your facility. You might actually just say, I need to normalize everything. I need to convert maybe some audio like you see on the top right, where I need to shuffle my audio around. So everything is the same when it ends up at the right spots. Or you can even put all of these functionalities or sources and destinations that you would have in Media Hub. They would become, and you can show them within a touch panel or in a physical button panel. So it really, the intention here is to create that user interface that for the end user, they actually don't really know that the signal comes from a remote site, goes through the public internet and ends up in their multi-viewer PIP or maybe in a control room. So for them, it's completely transparent. And that's, of course, what we're trying to achieve from an operational perspective. When we look at the different use cases, there was actually a few that we were brainstorming already a while back around that. But of course, the first one is that Cerebrum is very often already present in a broadcast control system or in a broadcast center. And what it would allow you to is that for the first use case is route to any destination. So even though this destination is not necessarily within your IP environment or in your SDI environment, or it could even be from SDI converted into IP through the internet to the local destination, that's something that you can facilitate. The other part that we were also thinking of, well, you very often have ENG cameras with TVU packs on them. Well, if you want to route easily into your control rooms, again, this can just be done with one push of a button, and you don't really have to think too much about it. Also, again, the openness of all of this. Use case 3 was more around, well, I have a truck that goes around the country, and it maybe has some Makito encoders, some SRT feeds. Well, again, here, Media Hub can help, and we can actually expose just as a source or a destination, and you just take it as you go, and it routes around. Same thing for remote commentaries. So all of these different use cases are basically around routing. When you allow for somebody to route from the broadcast center to a remote site, and this can be facilitated. And the last part, of course, is that when you look at the whole Media Mesh platform, it is not just about the routing. Media Hub as such is, of course, the routing part, but Media mesh can facilitate other functions, and you could even have maybe additional control rooms that could be part of your workflow. And again, but it's important that there's still going to be signals coming back from that remote control room, or you're going to have controllers that will be sitting in your broadcast facility, or people will be operating from your broadcast facility, and they want to have familiar interfaces. So here again, all of these user interfaces or use cases can be controlled from a Cerebrum perspective, leveraging or working together with MediaHub and Media Mesh as a platform. So we're trying to really create the solution offering, optimize the production needs, optimize the fact that you don't have to think too much about what actually complexity sits behind, and the combination of both can actually offer that without any specific vendor lock-in. So that's quickly in a nutshell what we've done so far.
Right. Thank you, Dieter. So let's move on to questions. We've got a few questions, but if anybody else has any, please do put them into the Q&A tab as we go through these. The first question is for Mike. Is there an ability to run MediaHub, the API, in your own VPC?
Yes, absolutely. There's a small little piece of software called TVU Agent. You load that on in your VPC. It connects to the control plane. We download any of the microservices that are needed, but you can run that data plane in your VPC or your facility, on premise.
Great. Next question is for Dieter. How easy is it to add TVU MediaHub to Cerebrum for existing or future customers?
Yeah. So of course, I mean, if you're an existing customer, you might know what generic device points are. So out of the catalog of all the APIs that we have, we don't really charge per integration point, but we charge device points or integration points for that. So if you already have generic device points, you can just connect to the system. So it's fairly easy to extend as well. You can just buy additional points and add them to your existing system or buy a new system. From there, I think I counted yesterday or the day before, it's around 5 or 6 different clicks. So you add TVU as a cloud orchestrator, you add the device, you of course have to do all your credentials for the security, and then once it's added, it automatically pulls all the information of the sources and destinations that are configured in MediaHub, and you're basically good to go.
Okay, thanks, Dieter. Back to Mike. What's the general business model for TVU Media Mesh?
So TVU Media Mesh, its business model is for the connectivity, the remote connection service. It's priced to be very attractive, versus other types of connectivity solutions. So there's a marginal per gigabyte charge when you're going out of Media Mesh, and then for the services that some of the things that Dieter mentioned, conversion, 50 to 60 hertz frame rate conversion, all those things, those are priced in the cloud, really on an on-demand basis. And then when you're on premise, there's a monthly fee for CPUs under management, more like, and on premise, it's more like a CapEx type of model. So it's a fixed cost that no one can predict. When you're in the cloud, it's more of an elastic cost because you're just bursting up to do it.
Back to Dieter. Could anybody within the broadcast facility route MediaHub signals around, and could it be extended to other users outside of the broadcast facility?
Sure. So, of course, in the facility, everybody who has access to a Cerebrum UI, could be a panel, could be a touch panel or a web interface, or a full client, they can, of course, access it. Everything is driven by user rights. So I think that's still an important one, because you don't want anybody to take away a feed somewhere. So user rights are quite important. But this can also be extended outside. So we have also the ability to deploy web clients with also reverse proxy security and single sign-on capabilities. So we can actually deploy anywhere we want. Of course, you need to open up firewalls to allow for remote connectivity, but that's all possible.
Fantastic. Okay. Back to Mike. Could you run us through an example of how to get NDI from the ground into NDI in the cloud infrastructure?
Yeah, be happy to. So as I mentioned, Media Hub, Media Mesh can run on premise. So typically, let's say you have NDI in your LAN in the facility, and you want to get that to the cloud. We can receive NDI, and we'll move that into the cloud. Again, shared memory connection, and then we can make it available in your VPC. In the cloud.
Right. How much bandwidth, I guess this is for Mike as well. How much bandwidth is necessary on the ground for average per stream?
Yeah. So great question. It's configurable, but what we do is depending on where you are and what you're trying to do, there's a cost for bandwidth, is between AZs and AWS, or between regions, or going out to the internet, different bandwidth costs. And so we have three ways that we implement shared memory. One is completely uncompressed, which is obviously high bit, 3 gigabits per second for 1080p. But we also, if the distance is more appropriate, we will compress in JPEG XS and then decompress on the other side. And for super long distances, we compress into H.264 underneath the hood.
And I guess a similar question, how does Media Mesh handle different network bandwidths?
Well, yeah, that's effectively what we do. So our connectivity orchestration system has a cost function, and parameters can be set so that you optimize for the cost that you're able to handle under the three uncompressed, JPEG XS or H.264.
Right. This is sort of timely and forward thinking, but is there a way to keep 4 cameras in sync when transmitting through TVU Media Mesh?
Yes. So this is one of the things that I got very excited about with Media Mesh is timing is a first-class citizen in the system. And so we receive and take timestamps from many different sources, as long as it's NTP or PTP, and there's you're locked there. If there's not a timestamp, say it's SDI just coming in, we can timestamp it on input, and we respect that through the system. And so as things are set, through the internet, there's jitter and things like that. We do asynchronous processing. We align the timestamps where they need to be aligned. And so keeping 4 cameras in sync, for example, is something that we natively support. And so there's many exciting things about timing that we see in the future that we can work on.
Right. This is a question for both. When is the integration with when is Media Mesh able to test and POC, and when is the integration with Cerebrum ready to go? So let's start with Dieter and then go to Mike.
Yeah, sure. Thank you. Well, yeah, good question. So today we have some early versions that we also used at IBC to demonstrate all of that. So the official availability is at the end of October. So that's basically, yeah, in a few weeks. Then it becomes available for everybody. But yeah, as with Mike, we already did some testing. So if there's anybody interested, of course, we can try to accelerate, but the general availability is at the end of next month.
And Media Mesh, again, it's the platform that we've been developing over the last 10 years, and we're exposing the APIs. And Media Hub was introduced about a year ago. Those components are available. The remote connection service, I would classify as limited availability. You can test it and POC it now, and so that's where we're at.
We've got some more questions about latency, so maybe we'll combine a couple of here. What is the average latency from ground to cloud or cloud to ground? And how much latency does Media Mesh add? You want to do
Yeah.
the two together.
So Media Mesh, so first of all, that question, people say, well, it depends. Well, of course it depends, but let me try and give you a sense. We were like at IBC sending SRT from California into the AWS Dublin data center. That we were doing about a second less than SRT. And then in the cloud uncompressed, we can go, even cross a crown across VPC in the same easy with about three frames of latency that's uncompressed. And so there's obviously, physics and there's noisy networks, and so there needs to be some amount of compensation for that. But I would say that our latencies are state of the art.
You can't beat physics, right? So.
Yeah, exactly.
All right. I guess moving on, more about Media Mesh, how does it handle redundant ISP connections?
So you can, it's one of the nice things about shared memories is it's multiple people can read the same thing. So it's very easy to take two redundant ISP connections, bring them into the cloud, and you can decide when you want to have the switchover point. But it's very easy to do kind of cross connects with shared memory and build very redundant systems with this technology. And in fact, many of our customers do that today, and that's a key aspect of it.
Right. We are coming up on time, so I want to thank everybody for joining us today. We had a significant amount of people joining us today. One of the questions that we got is, will the session be recorded and distributed to our participants? And it absolutely will be. But I want to thank Mike for joining us and explaining a little bit about Media Mesh, and especially Dieter for joining and giving us the overview of Cerebrum and the integration with TVU. So we really appreciate it. Thank you, everybody, for joining us today. I think we've got a slide, a QR code here to show if you want to book a follow-up meeting. We'll leave that up as we're finishing here. Those QR codes can be used to book a meeting with us, or to, if you are interested in creating an application using one of the TVU Media Mesh development methods that Mike gave an overview in his section. You can do that. That will take you to the appropriate spot. So thank you, everybody. Dieter, again, thank you so very much. We truly appreciate it. Thank you, everybody, for spending the last 40 minutes with us. We're really excited about TVU Media Mesh. Dieter, any last words?
No, I think it was great collaborating, and it's also great to see that this open APIs makes integration quite easy. So that was a nice one to see for us.
All right. And Mike, you can have the last word.
Well, let's stay. Thank you, everybody, for joining. Thank you, especially to Dieter and EVS. We're looking forward to a lot of great things in the future as well.
More to come, for sure.
Thank you, everybody. Have a fantastic day. We really appreciate you joining.